In this video, we'll be learning about Newton's second law of motion. And Newton's second law of motion is often stated as, when a net force acts on an object, it accelerates in the direction of the net force. The acceleration varies directly to the net force on it and inversely to its mass. Newton's second law is represented by the formula F net equals ma, and F net stands for net force, A stands for acceleration, and m stands for mass in kilograms. And F net is measured in newtons, which is a kilogram times a meters per second squared. So we will be solving a question, and the question states that an object with a mass of 15 kilograms rests on a frictionless horizontal plane and is acted upon by a horizontal force of 30 newtons. And so the first question is, what is the acceleration? So we know our F net is 30 newtons, and we know our mass is 15 kilograms, but we don't know our acceleration, which is the question. So we're going to use the formula F net equals ma, the one that we just went over. So if we plug in the numbers, our F net is 30 newtons, so we'll go 30 newtons equals, and we know our mass, which is 15 kilograms, so we'll go 15 kilograms, but we do not know our acceleration yet, so we'll keep that in there. Now to find out acceleration, we need to get a by itself, so what we're going to do here is we're going to divide 15 kilograms times a by 15 kilograms. That's a k there. Then what we do to one side, we're going to do the other. Alright, so then we got a by itself, and then 30 divided by 15 is 2. And then our units for this is meters per second squared, which we cannot forget because there's a vector over the a. So the acceleration is 2 meters per second squared. So that's the first part of the question. Now the second part is asking how far will it move in 10 seconds. Now of course we cannot use the F net formula for this question as well. So we need to resort back to our kinematics unit, and we're going to use the formula delta D equals velocity 1 times delta T plus 1/2 times the acceleration times delta T squared. Alright, so if we look at this formula, we know that we do not have D yet. That's what we're trying to solve. Our V1 is 0 because it's not moving initially. Our delta T is 10 seconds, so it's going to be 10. And then our A, we got A from the first part of the question in part A, which is 2 meters per second squared. And then once again we have delta T, which is 10, and then we're going to square that. So if we write this out, it's going to be delta D equals 0 meters per second times 10 seconds plus 1/2 2 meters per second squared times 10 seconds, and then we're going to square that. So right here we have 0 for V1, and anything times 0 is 0. So we're going to cancel that out. So now our equation looks something like this. The first part of the question cancels out, so that just leaves us with our second part. And so when we times this all together, our answer is 100 meters. So the object will move 100 meters in 10 seconds. And that is a question from Newton's second law of motion.